All right, let's look at another simple program. And this time we won't just look at the program in my slides, we'll actually try and work this out in Pruter. And that will also give you a sense for how to use Pruter better than what you got from my other video on Pruter. So let's look at this program. What does it do? So we already understand what the header line does. We already know what int main does. We already know what printf does, except that now printf looks slightly different than before. So there's some things that are different. Let's just quickly go over them one by one. This is a very, very important concept for us to understand at the beginning of the course. Rewind what I am saying right now and listen to it multiple times in case what I say is not immediately clear. When I say int a, then in the computer, logically, the computer operating system creates a box in memory which is big enough to store an integer. Now, that doesn't make sense. Integers can be infinitely large, right? So the way in which the computer understands int or an integer is a little bit more specific than our general understanding of an integer. An integer can be infinitely big. You will run out of all the computers in the world before you can find a memory large enough to store the largest possible integer. It doesn't exist. You can always find a bigger one, right? So forget about the mathematical definition of an integer. An int in C is a variable that can be stored, that can store an integer that will occupy no more than a certain number of bytes of space. And that number of bytes, as we'll see in the coming lectures, varies across different operating systems and different computer architectures. So when I say int a, the computer creates a box that's big enough to store an int somewhere in memory. And in this case, because I'm saying int a equals 1, it puts the number 1 in that box. Make sense? So you have int a equals 1, and it just says that you have a box of size, well, it's going to be 4 bytes if you have a 64-bit processor, and 2 bytes if you have a 32-bit processor. And that essentially, as we'll see further down in the course, imposes restrictions on how big an integer can be stored in that box. But for now, we're just working with small integers, so it doesn't matter. We put 1 into the box that is named A, and we put 2 into the box B. And then when we say int C, we create a new box, again with the same size. And when we say C equals A plus B, what the machine does is it goes and picks up the value in the box A, and it adds it to the value in the box B, and it stores the result of that in the box C. And some of you are saying, well, this is all straightforward. It's actually not. There's a whole lot of sophisticated reasoning that is going on under the hood, and I'm hoping that when we cover this topic again slightly further down the line, when, for example, we start talking about pointers, you will realize just how elegantly information storage and processing is implemented by C. It actually is really, very, very beautiful. Right now, it just feels like, oh, it's the most obvious thing in the world, but it's not. It's actually really subtle. So hold on to this this. And when we talk about pointers, I'll ask you what you think about the way in which memory is being managed in this program. So anyway, long story short, you have this equal and plus that are new um, tokens in this language, but you already know from your knowledge of math what they do, and so it's easy to understand that they are operators. Equal is an assignment operator, plus is an addition operator, and when you have two variables combined with some operator, it makes an expression, and the expression can be evaluated by the program and the output can be conveyed. You will also see that unlike in the program that we saw in the last lecture, well, not lecture, last video, you can put some spaces in some locations to improve the readability of your code. You will learn by trial and error where you can put spaces and where you can't put spaces. There are very many ways of writing code that has the same basic effect. I'm just showing you a few examples, but as part of playing around with Pruter, I encourage you to try and find even newer ways of trying to do this thing than the examples that I'm showing you. So, for example, you can say int a equals 1, or you can just say create a box of 5 int and call it a. Both are perfectly reasonable statements. And then later on, you can assign the value 1 to a. Or you can do something else. You can say, I'll just define int c as the assignment of a plus b. So I can do assignment and declaration separately like here, or I can do assignment and declaration together as here, and I can do multiple combinations. So here I am declaring A, B, and C all together. So I'm saying make 3 boxes, all of them of size int, and call them A, B, and C. This is allowed by C. I can also say I'll define int A equals 1, B equals 2, and C. So what this will do is it will create a box A and store 1 in it. It'll create a box B, store 2 in it, and create a box C and not store anything in it yet. Then in the next statement, I can say C equals A plus B. And then I will get an assignment for the C box as well. So there are many, many ways. And then you will say, well, how will I remember all this? It seems like this is anarchy. How do I know what is a correct piece of code and what is not? And the simple answer is that there's no golden rule except to just practice. And when you practice, it'll take just a few days to internalize. It's like when you started learning to ride a bicycle. In the abstract, it seems so hard. And what is the correct way to balance your weight on a bicycle? Nobody can tell you. But you start, you take a couple of spills, and before you know it, you know how to ride a bicycle. So programming in C is the same way. There'll be this 10 to 12 day window where all your programs will give compiler errors. And after that, it'll all be golden. You will have no problems. You will be very happy. So all you have to do is code. Let's do some coding, and that will make us happy. So I went into my code book on Pruter, and I picked up the practice demo lab. You will see I have all these folders because I'm the instructor. You only get to see this right now, so be happy with that. And I'm going to look at addition of 2 numbers, and I'm going to say let's start solving. So read the problem statement carefully. And it's asking me to do things that I haven't taught you yet, but it's not all that bad. Let's see. So what it's saying is use scanf. So there's a statement called scanf, which allows you to take inputs from the user, and you have to tell it exactly what the nature of that input is going to look like. So in this case, we just have to take two numbers, 1 and 2. Well, I mean, two numbers. So I'm saying percentage D, percentage D. Why am I doing this? So again, I'm getting a little bit ahead of myself, but percentage D is how you tell the computer that it's a number, it's an integer that's coming. The computer has no way of knowing whether what you're typing is a number, a letter, a decimal, or anything else. So you have to tell it. You have to tell it explicitly what it is that's coming. And again, there's some subtlety here that I will not explain, but instead of saying A and B, I'm going to say ampersand A and B for reasons that will become clear a few lectures down the line. I also have to declare the boxes, so I'll just say int A comma B. And now I have to say printf. So I'll say printf, and again, I'm going to say percentage %d because this is just a way of saying I'm going to be printing a number. And then I'm going to say A plus B. And that is my code. So I used scanf to take the input. That is what the problem statement read. Then I have to use printf to print, and I have to use the arithmetic operator plus to add. So now let me take two numbers. I'll take 2 and 3. And now I will compile my code first. So I compiled it, and you can see I got this green message saying that I did it right. Now let's execute the code. So I execute the code, and I can see that when I tried to add 2 and 3, I got 5. Now this is great, but let's see if we can evaluate the code. So you will see when you press run here, you will see that there are 3 options. You can compile, which basically is a way of saying that that you want your C program to be translated into machine language, and hopefully there are no syntax errors. You haven't written anything incorrectly, and so the translation is possible. Execute is after your code compiles correctly, you can run it and see if the logic of your code works. And when you evaluate, what happens is that under the hood, where you can't see, we have made multiple instances of possible inputs and outputs of the program. And what we do is we evaluate this program and look at what happened. There were 2 test cases. Now, what are these test cases? These are inputs that were predefined by the TAs, and essentially they're a way of verifying that the actual output of your program is not you trying to be a smart aleck and hard coding the output. So what would a hard coded output look like? It would look like this. So I would just remove this, I would remove this, and I would simply say print, oops, sorry, 9. So if I were to do this and I were to evaluate my code, you will see that one of the test cases is passed and the other one is not, because I hard coded my output. And the hidden test cases are the ones that you can't actually see. They exist only to the view of the TA and the tutor. And these test cases are ways of ensuring that if you play this sort of trick, you don't get any marks. So just keep that logic in mind when you do evaluations. So let me bring the old code back that we put in with so much effort. Now, when we evaluate this code, it passes all of our test cases. And so this is great. Now we can move on. Now, if this was an assignment, then you would see the option to submit the code. And once you've submitted the code, then you cannot change it anymore. So generally what we encourage is that you save your code, and then once you've completed everything and you've double checked, that's when you submit. Um, you can also submit multiple times, and we only count the last submission. But generally, we advise that you are sparing in the submission aspect of it, just to save your code. So this is an example of us completely solving a problem, and we see that the test cases are passed, which means that the program satisfies the technical requirements, and we can move on to solving the next program. And so don't wait. Go to your Scratchpad, go to your codebook, go to your practice, and do this. Let's do this, and let's meet on Tuesday and see what you've done.